Okay, so let us move on to the next set of examples. So we'll take an examples where we need to form a perfect square in the denominator. Integrals of certain functions. We'll try to take this one. Integrals of some functions. So some standard formulas we are going to take. Suppose if you are having dx by a square plus x square. So in that case, how we need to solve this set of examples. So dx by a square plus x square. However, we'll not be deriving the formulas. We'll just try to take these formulas directly. So you need to remember these formulas. So this is in the form of, this is 1 by a tan inverse of x by a plus the constant of integration c. So when you have integral of dx by a square plus x square, then the formula will be 1 by a tan inverse of x by a. So whether it is in the form of a square plus x square or x square plus a square, in both the cases, the formula will remain the same. Now let us try to see, suppose if it is a negative sign, in that case, how to write down. Suppose if you are having integral of dx by, if it is in the form of x square minus of a square, and in that case, how can we get the formula for this one? Now the formula that we have is 1 by 2a, 1 by 2a, 1 by 2a, because a term is there. So we'll be getting log of mod x minus a by x plus a plus the constant of integration c. So this will be the formula whenever you are having x square minus a square. But if I put the other way, a square minus x square, in that case, what will be the formula? Integral of dx by a square minus of x square. So here we have taken plus. You can observe here plus. Now what we are taking? Minus. If minus is there, the formula will change. So the formula will be in terms of log only. If it is x square minus a square minus of x square, in both the cases, the formula will be in terms of log. So it is 1 by 2a. It is log of, you're getting mod of a plus x by a minus of x plus the constant of integration c. So this is the formula. So you should be very careful. If you try to observe over here, if it is in the form of x square, if it is in the form of x square minus of a square, the terms that I am writing is, the numerator term is in the form of x minus of a, the denominator is in the form of x plus a. Whereas when you are having a square minus of x square, you are writing the numerator, because a and x, first a then x is there in the same order I am writing. Numerator will be a plus x, the denominator should be a minus of x. You have to follow the same order whenever you have this type of formulas. So both the formulas are similar, and accordingly you need to write down the formula. Right. Now this is the expression that I have taken in the denominator, but in the denominator if we get square root. So if I get the square root in both the cases, in that case, what will be the formula? So we'll try to take its integral of, it is dx by. So under root you'll be getting dx divided by under root x square minus of a square, under root x square minus of a square. So you have over here in this case, without root you're getting x square minus of a square. Now with root, the formula will be slightly different. So the formula will be log of mod x plus. Now since you are having root of x square minus of a square, therefore you will be writing down the same value, root of x square minus of a square. Let me put that minus sign properly. So x square minus a square under mod plus the constant of integration c. So can you see over here x square minus a square, just put the square root, then the formula has changed. Now let us try here, try for the third formula and put the square root for that one. So it is integral of dx by, it is root of a square minus of x square will be equals to. So once again, a similar formula we need to write over here, because it is root of a square minus of x square. But if you try to observe a square minus x of x square term which is there, it will not be in the form of log, rather it will be in the form of sine. So therefore we'll be getting sine inverse of x by a plus the constant of integration c. So if suppose if x square comes first, then a square comes, then this will be the formula log. But suppose if a square, the constant comes, then x square, the variable comes, this will be the formula. So you should be very careful while remembering this set of formulas. Coming to another formula that we are having, if you go back to the first formula I have taken a square plus x square. I have not put the square root for this. For all the other I have put square root. Now let us put the square root for a square plus x square. Then we will be getting integral of dx by under root. So there on the top I have taken the value to be equals to a square plus x square or x square plus a square. So I'll be writing down the value to be equals to x square plus a square. So when you're having here, when you have x square minus a square, you have written the same formula you'll be getting log of mod x plus root. Because here root of x square minus of a square was there, therefore I have written that one. But here what you're having, root of x square plus a square is there. Accordingly, you'll be writing down this value. Log of mod x plus root of x square plus a square plus the constant of integration c. These are the set of formulas that you need to remember.